just ensuring that someone who's hard of hearing or sight or no sight is still able to use the website, so as they navigate in audio mode, the dictation should be accurate to what's being displayed. If they can hear, then they should also be able to navigate just by seeing.
Yep.
Those are the two common ones that are easy to account for when you're doing accessibility content.
Excellent. Well put. Thank you. I would extend that, yes, it is about making it work for people who are hard of hearing to make it more inclusive, but I would extend it to the fact of it's just simply making your technology match the way people are attempting to consume that information. So it's, from a technical perspective, a way of describing information in a way that it can be understood in multiple ways of representations. So what's interesting about that is all of the things that get represented in accessibility are represented via text. And you know who else is really, really, really interested in using text? It's AI agents. So AI agents are piggybacking off of the decades of experience that accessibility practitioners have been building into our systems from the very start of the web. So accessibility assistive devices are using things like the accessibility tree. It's using keyboard semantics. It's using all of these other hooks into our systems in order to navigate and understand the web. But AI agents who are text-first creatures that are built and trained on using these text-based things are first going to be reaching for these same types of text semantics in order to understand their applications. So you'll find that many different systems that fail for AI agents, like if you have a GUI or something, a graphical user interface, that your AI is supposed to parse these different systems that they're supposed to use. If your accessibility isn't quite there, they generally fail because the same things that the assistive devices are using actually are what the AI agents are also using behind the scenes. So how does this all work? I'm making a lot of big claims, but how does it work? So the code that we write as developers, the HTML that we write, goes through multiple phases. You write HTML, but when it gets presented by your web browser, it's getting presented in two different modes. It's being presented, one as the DOM, the document object model. Whenever you're in Google Chrome developer tools and you open up that elements page, that's the DOM. That's the rendered version. That's the pixel version of whatever we're seeing represented. But the browser is doing something a little bit hidden that is actually hidden to most users, but it's creating something called the accessibility tree. And it's creating what's known as a semantic representation of that same information. So the DOM is taking in the HTML, it's taking in the CSS, it's taking in the JavaScript, and it's figuring out which pixels to draw on the screen in order to represent that information. But if you are blind, for instance, and you can't see the pixels on the screen, how are you supposed to interpret it? And it's through the accessibility tree that the browser also creates, which is, again, a semantic representation. It's meaning representation. So when something is a heading, it's called a heading. It's not just big text centered on page. Do you see what I'm trying to get at? So the DOM is for rendering. The accessibility tree is for conveying meaning. Any questions? Cool. So some other things that consume the accessibility tree. The big one that we hear in front-end development is screen reader development. And it's mainly, we talk about screen readers a lot in front-end development because it's kind of like the boss battle of accessibility, where it's the most extreme version of it, where we have no pixels that are being pushed to the user. It's all having to rely on these semantics. But there's a lot of other things that are relying on the accessibility tree, such as keyboard navigation. So without the accessibility tree and without us using semantics to mark up what is actually pressable by a keyboard, there's no way that the browser would be able to actually stop at that element and be able to react to any of those keyboard commands. I don't know if you've all ever heard of a switch device or a sip and puff, but a switch device is a single input device that basically is just going through a timer, and it goes one element by one element. And whenever you're wanting to work with that element, that's when you click on it. And then within that element, there could be sub-elements. Then you click on that. Sip and puff, it's a similar thing, except the joystick for it could be controlled by your mouth. And you can do a left click by puffing into it, and you can do a right click by sipping into it. Then there's voice control. So these are all for like motor disabilities. So if you're not able to use a mouse or keyboard or something like that, you want to click on that submit button for your form, you have to go click submit. And then what the voice application is doing is it's looking through that accessibility tree. It goes, what is a button on here that is named click or named submit? And I'm going to go ahead and perform that click action. But again, without that accessibility tree behind the scenes, it wouldn't be able to do that. It all would look the same. It would look like noise. And then finally, we get to AI agents, which is what I think most of you all are here for. But with exposing that semantics to the AI agent, because they're excellent at writing code, they're able to read these trees just like we read and write English. It's just being able to go, oh, this is a button. Let me go ahead and just consume this as a button. I know exactly I can hit spacebar or enter. I can write code against it. I can ensure that there is keyboard functionality. So when an AI agent tries to navigate the web first, it's first using the accessibility tree. And only then, when it's unable to understand the meaning from there, it falls back to using what we would consider as traditional ways of using the computer, which is taking a screenshot of it. Then it has to do a lot of really fancy things, like it has to annotate all the different regions on a screen. It gives them numbers to it. And then you have to use the internal reasoning and the multimodal, which means image and text inputs of the AI to be able to reconstruct what those underlying semantics are. So then it can hopefully perform those actions. So it's just way more simple if we can think of accessibility, our accessibility tree, that semantic layer, as the basis of our application. It makes it more inclusive for all who happen to be using the device. So how does it do it? And what is inside of that accessibility tree? And inside the accessibility tree are three main properties. You have the name, or what this thing is. You have the role, what type of thing this thing is. A role could be also thought of, if you're into programming, it can be thought of as a programming interface. It's like a promise to the end user of what kind of functionality to expect. So if I give something like the role of button, the user would expect a promise that they can be able to click it. They can use the spacebar or enter key to click it. They can also expect that their keyboard will focus on it, things like that. Value is what information gets stored within an element. So imagine you have an input device or input tag, and it's called name. And I fill it out. I type in Dylan. Its value would be Dylan. But when you're missing these name role values on the accessibility tree, it just gets rendered out to nothing. It just gets called container, which isn't very meaningful to anybody, especially if you can't see the context in which the pixels are being drawn. So the better example to use, instead of using a div like we have on the left-hand side for your submit button, is to just reach for that native button tag. And then you get the name of submit, you get the role of button automatically, and you actually don't get a value because a button doesn't need to have state in it, unless it's like a toggle button, where then its value, if it were like, do I want to sign up for this email newsletter, checked or unchecked, that's what value would be. But it's just a way of thinking about how are you conveying the essential information for any given element in your given HTML element. So here's another example of what your assistive devices or what the AI agent would actually be using for a navigation element. So on the left-hand side, I have a navigation element that's all built with divs. We have a class of nav, we have a class of nav item for the internal links, and we have our on-click handlers that could be handled by React. But what's really unfortunate is all of this beautiful work could be looking like, YC-backed venture capital, excellent. It could look beautiful, but to a screen reader, to an AI agent, all you get is generic, generic, generic. And this is quite literally what it types. This isn't just me being exaggerating. That's literally what it says. But if you use the semantic element, such as a nav element, it gives the benefit of letting the screen reader know, hey, this is a navigation. It gives a shortcut for software to hook into to jump straight to that navigation. But it also lets you add in things like a name to it via ARIA label, which allows us to specify that this is the main navigation. Then we have anchor tags instead of using divs, which then allows the accessibility tree to be reconstructed as navigation main, link home, link about, instead of generic, generic, generic. So it simplifies things. It's less hops that your AI agents have to jump through to be able to get to the same exact information, but it's also the things that create these invisible blockers for a lot of users who might be relying on the accessibility tree in order to understand something. So this is POUR, or perceivable, operable, understandable, robust. This is the core principles behind what's known as the Web Content Accessibility Guidelines, or the WCAG. This is the main body that people in accessibility, a lot of governments use as the basis for determining if whether something is or is not accessible. And I feel like it kind of gets dragged through the mud a little bit just because it's a little complicated to understand, and mostly people are striving for just conformance. But I would rather think of the WCAG as setting conditions for meaning. And the WCAG's main principles are: is it perceivable? Can it be sensed by any means? Is it operable? Can it be acted upon by any means? Is it understandable? Does it make sense? And is it robust? Can it react efficiently in various different types of technologies? So an example of robust is one of those esoteric ones that's hard to understand. But imagine you are disabled and you're in a wheelchair and you have a device that is mounted to your chair and it's stuck in landscape mode. But the designer designed the website so that it only works in portrait mode, but you can't move, so you're not able to rotate that device. That fails the robust principle. But this is not just a checklist for just obeying the law, but it's the threshold on which you can judge all of your interfaces on whether meaning is being transformed across all these different modalities. And this is becoming more and more important, not just for accessibility, but again, for our AI agents. Whenever you encounter something that's interactive on your page, can it be perceived? Can it be operated? Is it understandable? And can it fit within the constraints of your agent's environment? So perceivable, operable, understandable, robust is something to keep in mind most definitely. So what breaks when the accessibility tree, and what works when it is not working? So earlier, when Noah was showing off his slides, we didn't have the QR code loading, and its fallback was pretty catastrophic. It was just that icon. We didn't have any information being conveyed. But if we had an alt text assigned to that QR code, the fallback would have been at least the link to that destination that he would have wanted to have people go to. So in that catastrophic fallback in which the image data wasn't conveyed, we would still have the ability to reconstruct that meaning via just that text. But that goes the same for alt text for any types of images. If you don't have an alt text or an alt attribute assigned to it, in the best case, gets announced as just an image to the user. Worst case scenario, it'll read out the entire file name, which is a nightmare to listen to. And then for your AI agents, imagine you're having an AI agent that's helping you shop. And this AI agent isn't an image native being, it's reading all the text on the page. But what if there's some fabric details or something that are really important for you to know on whether it's going to be fitting you in particular? Well, that gets skipped. Or the worst case scenario for your AI, if you don't specify something, that's a chance for your AI to actually make something up, and it could actually make up something completely wrong. Div buttons for assistive devices. How do you interact with something that doesn't have any of the code behind it that actually makes it interactive? It basically just doesn't exist to your disabled users. But for your AI agents, it falls back to it just simply can't activate it. It's not operable because it doesn't have the keyboard click handlers, the keyboard handlers and the click handlers in order to activate that. No headings. What happens if you have no headings and you have thousands of characters on a page? It's just a noise of a flat wall of text. That makes it very hard for screen reader users who would have to listen to the entire body of text in order to understand everything. But same for your AI agents. It would have to consume all of the tokens in order to read the entire page before it's able to recognize, oh, you're actually just talking about this one small section. So if you use headings, it's able to select upon that small section that it needs, preventing context rot and making the AI agents perform much better. So by falling back to semantic HTML, it affixes things for your AI agents and your assistive tech. Same code, same fix, zero extra work, makes it work for everybody, including your AI. So my argument to you all is, don't think of accessibility as just an accommodation. It's actually the infrastructure in which we convey all things of knowing to all users. You never know who is going to be accessing your application and what means they are going to be accessing it which. We also can't predict which types of interfaces are going to be the future. And that's very much apparent when it comes to AI agents. As we've woken up to the importance of how AI needs to be able to understand our applications, it's really revealing this gap that we've had for decades in accessibility because we haven't been conveying meaning in code. We've been conveying meaning in pixels. But now the interfaces that we're relying on are no longer using pixels to convey that meaning. So we as developers need to figure out how can we represent our code, the user interfaces that we're showing, in more semantic ways that can be understood in all future UIs that we want to expose for our users. So my final takeaways I would like you all to have is assistive technology and AI agents navigate the web in the same exact way. They navigate via text, not pixels. They both consume the accessibility tree via the name, the role, and the value. By ensuring that you have a proper name, role, value for each of your elements along your main user flows, you can ensure that the accessibility is going to be working for both your disabled users, but also both your AI agents as well. And perceivable, operable, understandable, robust shouldn't be thought of as merely a checklist or a compliance, but it should be thought of as the conditions in which meaning can be transferred across modalities. And if you can build the semantics once, every single consumer, human, machine, can understand your interface. So that's all I got for you. Thank you all. Any questions? Just for
knowledge sake, when you do usually apply this stuff in like any web pages or any apps or anything for like people with not just people with disabilities or anything, like, do you usually put that at like in front of a web page or like in the first few lines of like when you put your information and your tags before you do anything like your headers and footers and all that sort of stuff? As a general rule of thumb.
Yeah, as a general rule of thumb, I always start with accessibility first because I don't know if you've ever heard of the principle of mobile first, where
Yes,
so it's like where you want to design your screens for your mobile devices first because it simplifies your layout. It makes sure that you have your core user flow in place first because it's a lot harder to take away information than it is to just add information. So by focusing on the core user experience from an accessibility standpoint first, by putting in the semantic tags instead of just making things look good from a div perspective, from a visual perspective, by focusing on that very first, you're making it so that it's just easier work. You just add on functionality to a good skeleton instead of trying to reconstruct the skeleton after the fact. Does that make sense?
Yeah, I get where you're coming from. It's just like, as far as like after you put like docu-type and that sort of stuff, like your standards stuff is, I'm saying the first few lines of like any kind of HTML, CSS, or JavaScript.
Yeah. So like accessibility isn't just part of like the head of the document. It's all the decisions that you make on like what tags you use to describe your interfaces. Like, do you use a nav element versus a div? Do you use an article versus I just keep saying div because everybody uses a div for everything. That's what I'm talking about. Any other questions?
So, hi, I'm Asim, and I come from a design and development background altogether. So, see, I'm not been in the US for very long.
Mhm.
So, if someone has to familiarize themselves with WCAG, what would be the best resource in their opinion? Like, if there's a course that I could follow,
Yeah.
would you recommend anything?
So there's a couple different good resources. The first resource I would recommend for just knowing the basics of accessibility, this is a free resource. It's the WebAIM WCAG checklist. So they have taken this really terse, kind of hard to understand, very technical documentation from the Web Content Accessibility Guidelines, and they break it down into human readable, understandable bullet points that you can go, oh, this image needs an alt text, and this is why. So that's kind of how they explain everything. The other free resource I would recommend is using Axe Core. It's Axe Core or Google Lighthouse. Google Lighthouse also uses Axe Core inside of it. But what that does is it does static code analysis for accessibility issues. So anything that can be revealed via code is revealed via code. So it'll point out any accessibility issues that you have on your page. And if you don't understand any of those issues that it's reporting, just copy and paste that into an agent. And an agent is excellent at explaining what these issues mean in context of your particular screen. And then if you're wanting to learn more about accessibility, but this isn't a free resource, I am a big fan of DQ University, DEQUE University. It's a paid course online on digital accessibility, and it will teach you anything from the different models of disability to how to write code that is inclusive and how to use screen readers and other assistive technology for manual testing. Right. Any other questions? Yeah.
Are there any specific security considerations for the accessibility stuff? Like you have to worry about injections like you would on a cross-site scripting or anything like that?
Not particularly. The only thing that is kind of security related to accessibility is that you are making the content more machine readable, which then inherently could leave you up to like maybe bot scraping or something like that, because there's that same, by making things inclusive for screen reader users, you're making it more inclusive programmatically. So that's the only thing that I would worry about from security, but otherwise everything is pretty baked into the browser itself. So as long as you're depending on the browser security, you should be good to go.
So this is a statement, but we can assume there's a question mark at the end of it. Based on what you were talking about, where by adding the roles and the labels, it is more accessible to AI, does that mean that if I'm using AI to generate front-end based code, by actually including all of these elements, I will burn less tokens over the long run because it's able to more easily understand what I'm writing? So not only do you get the accessibility bonus, but you also get the saving on like token expenditure context. Is that a safe assumption?
It is potentially on the generation point, maybe. I think it would actually be spending more tokens up front when you're coding it to do it accessibly, because unfortunately the models haven't been reinforcement trained on accessibility, so they're not doing it by default. But if you put up the accessibility requirements up front, it's able to generate inclusive code. But then what happens is on your user side, when they're using agents to consume your application, they get to use less tokens. So you are producing higher quality code for the benefit of your users down the line. Nice.
Sweet. Well, thank you.
Thank you.